Hello and welcome to yet another video coming from the OCR GCSE computing course. Today we're looking at the 11th topic, which is all about images. So let's get straight into it. So first of all, we've got to look at pixels, and I should mention before we start that in this video we are focusing on a type of image called bitmap images. There's also vector images. So a bitmap image is, you know it's a bitmap because it has the extension BMP. So we're looking at bitmaps today because they're probably the most simple to understand. So most images, such as a sketch someone's drawn or an actual photo of something, they're an example of analog data. And as we mentioned before, analog data can't be used by a computer. It can't interpret all the blends, all the lines, all the data sort of being continuous. It has to have digital boundaries, and so it has to digitalize the images, converting them to a digital format, which is binary, as we've looked at. So yeah, images are no exception to binary. They're just a series of pixels represented in binary. Let's look at how an image is transferred from analog to binary. So this is a photo I actually took in America when I went on a holiday. So where it works effectively, this isn't quite how it works, but you don't really need to know. Effectively, a grid is placed over the image. The computer places a grid over the image, and each square is a pixel. And what the computer does, it finds the average colour in each pixel. Naturally, this grid is way bigger than it would actually be, because this would just be a series of dots. You wouldn't be able to discern anything from it. So it finds an average colour for each pixel and assigns it a binary value. So for black and white, this is very simple. It can either be black or white, so 0 or 1, as in just black and white, not grayscale. Grayscale can just be black and white, and the blends in between. For just black or white, it's simple, it's just 0 or 1. And for colour or grayscale, it's slightly harder, but every colour fortunately is just a mix of our primary colours, which are red, green and blue. So what happens, depending on the colour depth, which is the next thing we'll look at, each pixel is represented as a specific shade of either blue, red or green. So let's look at that slightly further. So colour depth we've got to look at, and some people call this bit depth. It means the same thing. So the colour depth is the number of bits that can be used to represent the colour of a pixel. So for example, if a 4-bit depth was used to represent each RGB colour, then there are only 3,375 combinations that can be shown. So we know that a nibble 4 bits represents up to 15. 1111 equals 15, and so 15 times itself 3 times to work out how many combinations there are. There's only 3,375, which actually aren't that many. So if a byte is used, so 8 bits, then a total of 255 to the power 3 colour combinations can be used, which is a huge number. That's 5 times better. So if we look at, for example, say 3 images, again, of this little chipmunk that I took in America. So what I've done, I've gone into Photoshop, and as you can see, I've basically edited the file so that the bit depth in each image is different. And these are just screenshots from the Properties tab. So you've got a bit depth 4 here at 125 kilobytes, a bit depth of 8 at 239 kilobytes, and a bit depth of 24 at 713 kilobytes. So one thing you could say between these two images there's not much difference. You can see this is slightly clearer, the colours are slightly more vivid, especially with the trees. The greens are slightly better here, quite a lot better actually. But there's not a huge difference. There's not as much of a difference as there are between 4 and 8, because as you get more and more colours, they all sort of blend together. So if this is a bit depth of 100, it wouldn't be so much better than this. It wouldn't be loads better because the clarity isn't quite the same, and the camera is probably not up to recording a bit depth of more than 40 or something. So yeah, we don't really need to know about the colours, but all you need to really know from this is that colour depth, you need to know what it is, and you need to know that an increase in colour depth, so a better colour, so an increase of this bit depth or colour depth, equals your size of your file will be a lot bigger. As you can see here, the difference in size of the files is bigger because more has to be stored. More binary numbers have to be stored alongside the file. So also you need to look at how resolution affects the file size. So quickly, resolution is a detail the image holds, that's a definition, and it's measured in DPIs, dots per inch or pixels per inch. So you can think of this as the grid being used before being more detailed. So we've got 2 grids here, 2 images. One grid is quite big, quite a low resolution, one's really small. Well, not really small, but quite small. Just an example. It's not totally how it works, but yeah. And as you can imagine, this is going to be, if it finds an average colour, this is going to be far less detailed than this, because the average colours is just going to look like lots of squares on the screen, this is going to look slightly better, not much better, but if it was a lot smaller and had a high resolution, lots of dots per inch, it would be a better image. So naturally, a better resolution results in a bigger file size. So that's what you need to know. Finally, let's look at the concept of metadata. So you may not know what metadata is, it may be a new term to you, and what it means technically, meta means data, and so it means data about data. So this is the data about a file that's automatically stored with it. So every file stored will have some bit of a metadata to it, unless it's a really simple file. So photos, videos, Word documents will have some metadata stored with it. So in the context of images, so if you look at images only, if a picture is taken by a camera, the camera may additionally save some information about the image. So for example here, again in the properties tab of an image and details, you see there's all these details about the camera. There's others as well, and here for whatever reason my camera didn't record anything for it, which not every camera does, but this can be useful, although it's not important, because it may be useful if you upload to Facebook or a video or picture showing website. It may list these details, I'm not sure, but so yeah, it's not important, but some important things must be stored in the metadata. Examples of this include the height and width of an image and the color depth, and they may be used by an image viewing program to display the image in the intended way. So when an image viewing program opens a file, it will look at the height, the width, the color depth, and it will know how to show it on the screen, which is why metadata is important. So that's it for today's video, quite a brief video in the general scheme of things. And next up, we're looking at how sound's represented, so hopefully you'll join me in that video too. Bye.